So go straight on to question 1 then. So let's have a look at this. So I can see a multiple choice question. There's a number of graphs in here. What's the information that's given to me in the question first? What's the key thing they're telling me? Well, actually, they're being very nice that they've given me a formula here. And they're telling me that this equation is true. And then I've just got to find out which graph is true. So is there any other piece of information that they've told me in there that's leading me towards how they want me to answer the question? Well, something that I'm suspicious about is saying why they're telling me that there's a constant braking force. So the fact that they're telling me that there's a constant braking force, well, now I've realized that if there's a constant braking force, this thing over here is constant, therefore work done must be proportional to braking distance. So I know that work done is proportional to braking distance. What do I know about graphs when they're proportional? It has to be a straight line through the origin. So now let's have a look at all of them over here. So the only one that's a straight line through the origin is going to be A. So I know that this is going to be the right answer. So that was pretty simple just by going, I'm using the formula that they're given, and I'm just talking about proportionality here. Now in the real exam, they might not be nice enough to give a formula. You just got to identify it from the stuff that's on the axes, and then you're looking, okay, what's the relationship between the stuff that's on the axes? And that's the way that they might do it in the real exam. Okay, so the next question, it's a nice 1-mark question, one of the ones I'm always looking for, which is about, it says that the energy is decreasing. Now, as soon as there's something about energy decreasing, losing energy, why isn't the final energy the same as the start or something? What's happening to the amount of the energy? It's always the same answer. So what's happened to the kinetic energy during braking? So the kinetic energy is transferred to thermal due to friction. And then I've got to say, what's the friction between, well, first is during braking, it's going to be, or I say to thermal to the surrounding, sorry. Due to friction, I've got to say what is the friction between, well in this case it's going to be between the brake pads and the wheels. So it's always the same thing. I'm looking for an excuse to say all this stuff here. So transferred to surroundings as thermal. Where's thermal? Oh, there it is. Due to friction, and then I'm going to say what the friction is between. I'm happy that one's right now. So seeing this question straight away, question number 5, I can quite clearly see that's an experiment question because it's saying a student investigate. So if it says investigate, experiment, anything like that, I know that I'm going to have to use the same method that we've been learning, that we've been practicing about about investigation questions. This is always, it's going to get me the full marks every single time. Like I just know it's going to. So as long as I do this, I'm happy that I've got full marks. I'm going to be so happy moving on from this question that, yeah, it's done. So what's the first thing that I need to do? I need to make sure that if there is a formula for this question, I'm going to write that one down first. After that, it's going to be the measuring equipment and what I'm measuring with it. After that, it's going to be a method, and there's a way that we've said we're going to try to do it if we can, but I might not be able to do that. It might just have to be some other kind of detail. After we've done the method, I'm going to say repeat and take an average, and then if I can for this particular one, I'm going to say do a graph of this against that. Now again, I don't really know if I can for this question yet, but if I can, I'm going to do it. If not, well, as long as I've got those other things, I'm sorted. Okay, so let's have a look at the information that they're giving me and see if there is a formula that I can use for this question. So it's telling me that it's projected up the track, travels up the track, rolls back down. And what I'm looking for is how the mass of the trolley affects the vertical height. So I just want to know how high it goes, and it's not saying anything about having to do any calculations or anything like that. And it's not, because I can just measure the height directly, I can measure the mass directly, so it doesn't look like there's a formula there. So, I mean, there's just going to be no formula here. So that's okay. Now I can just move on to the measuring equipment. So normally if there's a formula, I'd go through the formula and say measure this using that, measure this using that, going through the formula. But now I've just got to do the same thing, but I've just got to work a little bit harder maybe and read the question again and see what's in there. So what are the things I'm going to have to measure? And when it says something about the spring always exerts the same force, so because that's the case, I don't really care. I'm not going to have to measure that. It says investigate how the mass of the trolley, so I'm going to have to say measure the mass. And what am I going to use to measure the mass? I'm going to use a mass balance. And then it says is measure the height that it goes. So what I'm going to use to measure the height, and because it said vertical height or maximum vertical height, I'm just going to use the terms that they say as well. So I'm not going to write out in full because I can't be bothered, but obviously you have to. So maximum vertical height using a ruler. And then, okay, is there anything else that I need to measure? Not really, so that's okay. So I've done that. Now I'm going to go on to the method. So what is the method going to be? I know that I'm going to fire it from the spring and just measure the height. So I'm just going to say that and measure the height. And is this one where I can say change the something and measure the something? Well, yeah, it is, because it's saying how does the mass of the trolley affect the height? So I'm going to say change the mass, measure the height, and obviously again you need to write out in full. But this is something where I can say change to something, measure something, so I'm happy that I've got that one right. I'm going to say repeat and take an average. Always got to say repeat and take an average. And then is this one where I can say plot a graph of something against something? Yeah, it is, because I can plot a graph of the things that I've just changed. So I'm going to say plot a graph of mass against height, and always obviously write it out in full. And then I'm pretty happy that I have got this one right. I've definitely got full marks for this question. Okay, so I've seen a graph, and as always, I'm never going to relax until I've taken reading from the graph, or annotated the graph, drawn a graph in some way. So let's have a look at the question and see what opportunity they're giving me to draw on the graph. So it says the student says that the energy transferred by the spring is the same each time it's used, and it tells me use data points from any 2 points of the graph to support that statement. Okay, so obviously I'm going to have to have a look at, I'm looking for the energy there, and I've been given height here, I've been given mass here. So is there a formula that links together height, energy, and mass? I'm looking for energy. I've been given mass. I've been given height. If I can't think of one, I'm going to look in my formula booklet, but hopefully I should be able to remember one. And I've actually got one now. Yeah. Okay, whether I've remembered or looked it up, I now know that GPE is a type of energy, so I'm going to write GPE equals mgh. Well, it didn't tell me G, but remember, it's my job anyway that I should know what G is, and I know that G is 10. So I don't even need to write that separately, because now I'm just going to do the calculations. So now I'm going to show the examiner that I have got any 2 points from the graph, and I've just got to do that same thing twice. So I'm just looking at any nice points over here. Well, to be fair, this is a very nice point because it's on that line and it's on this line over here. So I can see that when the mass is 0.6, the height was 0.23. So I'm just going to do that calculation first. So I'll just label this point number 1, so the examiner can see very clearly what I'm doing. So point number 1, GPE equals, I've already written the formula there. So what's the mass? And it's in kilograms, so I don't need to do any conversions. So 0.6, what is G? I know that G is 10. And what is the height? And it's already in meters, so I'm happy with that. And the height was 0.23. So I'm going to get my calculator, and I can see that the answer is, I better get the calculator out. So 0.6 times 10 times 0.23, and the full number from the calculator is 1.38 joules, and then I'm always going to round to 2 significant figures, 1.4 joules. Okay, so now I've just got to take a second point, and again, it doesn't matter what point I'm going to be taking, but I need to show the examiner that I'm doing it. So I can take this point over here and that point over there, and I'm drawing the lines on there to show it. And to be fair, I could have drawn a line down there as well, so I was doing the first one. So I'm showing that this is the case over here. So for point number 2, I've labeled this one over here point number 2. And I'm going to do the same thing, GPE equals mgh. So GPE equals, when the mass is going to be 1, G is still 10. And here I can see that the height is 0.132468. So 0.138. I put that in the calculator, and I'm seeing that the answer is going to be 0.138. Oh, sorry, 1.38. I forgot to multiply by 10. Equals 1.38 joules. I'm going to round to 2 significant figures, 1.4. Jules, is that the same? Yeah, it is. So because it's the same, I'm going to just make a little statement here. Both answers are the same. Therefore, student is correct. Now, even if both answers weren't exactly the same, as long as my conclusion matches my numbers, that's okay. So it might, the question in a real exam might say, oh, is the student correct? This one says to support the statement. So it's telling me that it's correct. So if the numbers were slightly different and one said something like 1.38 and the other one said 1.39, I'd say they're both roughly 1.4. So it's going to be right. But if it says, is it correct? And both numbers are roughly the same, I can still say it's correct. If they're completely different, I'm going to say, no, it's not correct. But for all of these ones, as long as your conclusion matches your data, that's okay. So if it was like a little bit iffy and you thought it was close, but it's not exactly the same, as long as you're saying it and justifying it, you're not going to lose the mark. You're still going to get that mark the same way, as if the numbers were exactly the same. So just make sure that you're writing a conclusion that matches your data. And like I've done here, just don't just move on after calculation. Get into the habit of saying, yeah, the student's correct, yeah, or it's incorrect. Always linking it back to the question.